coming up that's going to drive that home. Okay, so we have, where'd it go? We have the password. We'll be getting into 19. Can't access, should use the set UID binary in the home directory. Execute it without arguments to find out how to use it. Password for this level can be found in its usual place. Okay, cool. So there's a set UID binary, Bandit 20 do. So Bandit 20 do. Run a command as another user. Okay. Let's just run ID. So what this tells us, so what ID does is it just kind of tells us who we are and who we're operating as. It tells us that we are Bandit 19 of Bandit 19 group. However, we have an effective user ID because we're using this set UID command. We have an effective user ID of Bandit 20. And we also are in the Bandit 20 user group as well as the Bandit 19 user group. So if we do this by ourselves, we're just in the Bandit 19 user, Bandit 19 group, and then we're only part of the Bandit 19 groups. So you might have been able to figure out that what set UID commands do is they allow you to run a command as a different user. A very famous example of this, though you might not know it, is the ping command. The ping command requires that you set up connections or sockets on you have to set up sockets, which is a root level thing to do. You can't, as a user, do stuff like that. So ping was set that way. I think newer kernels operate in a different way. This might just be my age showing, but newer kernels might operate in a different way. But for a long time, set UID or ping was the most famous set UID program that nobody knew about. They are useful because ping, but they are also very scary because they don't always end up being used the way you intend to use them. People are never assume that the person using your program is using it with the same intention as you are for writing it. For instance, so this might have been something silly, like I want to be able to, write, I don't know, read a specific file or run a script as that person when I don't necessarily need to be that person. Well, let's see if we can do something silly with it. That didn't work. Okay, cool. Well, that's good, right? So it only seems to be certain binaries that will allow you to run. Maybe only built-in binaries, perhaps. So what about cat? So if we cat etc said it was located in Bandit Pass, and then it's Bandit 20, right? And there it is. So even if you do have certain restrictions on it, like you only want to be able to, you don't want to be able to run bin bash or bin sh or something like that, they might still be able to get something nefarious out of it, like reading your password file or reading documents of your own, that maybe you have sensitive information in. So set UID, again, very useful, but very scary. Okay, so let's into the 20s now. All right, getting there. Now there is an SU Connect. Let's see what this guy's doing. Makes a connection to localhost on a port you specify as a command line argument. then reads a line of text from the connection and compares it to the password from the previous level. If it's correct, it will transmit the password. Okay, so we need to log in twice. And my headset turned off again. Hopefully that's not like some loud screeching or something when that happens, but all right. Okay, so we actually have two windows up, which is good. So we will sh bandit.labs.overthewire.org l bandit20. So we're gonna pick a random port to listen on. Let's see. Good, cool. And then we're going to su connect on to 5214. And then we're going to paste in the password for the previous level. And so what is happening here? We set up a listener. Then we run this command, which connects to a port. So we get that. Like, we get that connector. We get that connection. And then it just sits there waiting for input. So we provide input, it receives it, and it says it matches what we're looking for, so sending the next password. This seems silly, right? I mean, this is dumb. Who's ever going to write like a su connect kind of thing? But that's not necessarily what we just did. What we did is set up our own listener, connected to it from another place, and then are able to transmit data back and forth, right? What essentially we did is set up a listener and connected to it with a reverse shell. This NC minus LP is going to be very interesting to everyone who tries to do, who wants to do any sort of penetration testing or offensive security or playing around with offensive security. Setting up listeners, connecting to them, sending data back and forth, basic stuff like this seems silly in a war game, but really it's setting a foundation for other skills. It's getting you used to seeing things so that when you actually see it in a class like the PWK or the network pen testing class from SANS, the GPen, you'll already kind of have an understanding. You're like, oh, I've used that netcat command before. I've connected to it similar to this before, and now we're just learning advanced functionality. So here is the password. Cool. Let's move on. It's running automatically at regular intervals from cron, the time-based job scheduler. Look at cron D for the configuration and see what command is being executed. So if we ls etc cron.d, cron job bandit 22 is probably the one we're interested in. So let's cat etc cron.d cron job bandit 22. Okay, so it is changing the permissions of this temp directory to read write read write read maybe. Hold on. Maybe 4.4 is read. Okay. That would make sense because it's read write execute, so it's 4.2.1 maybe. I always forget about those, the actual bits, what the actual bits mean. So can we just cat this then? because it sets the permissions of the file, and then it cats the contents of this file into that file. So what happens if we just cat that? Okay, cool. Nothing funky there. I imagine that was just the first of many levels of frustration. Okay, so if I remember correctly, there's a etc cron.d cron job bandit, and then we'll be 23, right? Nope. Okay, so his name. Okay, so it's taking the password for this level, which is Bandit 20. This is being ran by Bandit 23. So my name equals Bandit 23. So catting etc bandit pass bandit 23 into temp my target, and my target is okay, the target is going to be this. So if we go echo I am user bandit 23, and then we MD5 sum that. Okay, I see what it's doing. So remember when we said that the $ parenthesis close parenthesis means that you're taking the output of whatever's in here and setting that, setting this variable to that. So my target equals the output of this entire string. So here it's saying echo I am user and then whatever your username is, which is bandit 23. So we did that here, and then you pipe that into MD5 sum. MD5 sum is going to give you the MD5 sum itself, and then I believe that's the name of the file that it MD5 summed. If it doesn't have a file, then it's a dash. I think that's right. It might not be right. It's not super important for this because all the cut command is doing is saying cut using the delimiter of spaces. So these are, this is the space. I want field 1. So it separates this from the dash and then just grabs the first field. So for our purposes right now, it doesn't even really matter what this is, but I'm pretty sure that's what it is. If this would have been a file, let's see. So cat or yeah, that's exactly what it is. So if it's from standard in, probably it's just a dash. But so this is our we need to go into temp, so cat temp, and there we go. So just to recap, maybe I blew through that. So here we've got a bash script. This front line is just telling us what we need to execute this script with. So this is a bash script. You've probably seen things like user bin Perl or user bin env Python or user bin Python or whatever. That's just telling the interpreter which interpreter to use, what shell to use, etc. So then it sets a variable called my name, sets it equal to the command of who am I, and who am I? It's just a command that gives you your username. Then my target is set to the output of, and then we did this here, right? Echo I am user bandit through MD5 sum, which is just a hashing algorithm. It gives you this hash. And then it outputs, it basically says that I'm copying the password file, this password file to this target. And then it actually does it. It takes the contents of user bandit pass who am I, which is bandit 23. So user bandit pass bandit 23, and then temp the hash of this. So it'll go into temp and then this long string. So we just cat that file, and here is the password we need. So Look here. And once again, we have another cron based challenge. So let's once again take a look in etsy cron.d, and we'll cat etsy cron.d cron job bandit24, and of course it's going to be in user bin cron job bandit24.sh. So we'll cat that. Okay, so cd var spool bandit24, because that's who they are, executing and deleting all scripts in var spool bandit24. So as bandit24, it's going to execute this script, and this script is going to go into var spool, and then for each file in each file that either has a dot or not, do this. If I not equals dot and I equals not equals dot dot, and basically what that means is so it won't execute and delete self or parent, and is making sure that it doesn't try to do anything on the special directories. It'll go in and it'll say I'm handling X file with a timeout of 9 to 60 seconds, I would assume, with a timeout of 60 seconds. Let's see what timeout does. Man, timeout. What does the S do? Signal. Oh. With a signal of 9, which is basically you cut it out right now, I don't want to wait for anything. Timeout of 60 seconds, do this. Once it's done, once it either times out or it finishes running, it'll rm force this file. So all it's doing, if we look in var spool bandit24, there's nothing there. So here's what we want. We want to cd var spool bandit20, or actually let's do it here. Can we do it here? Let's make dir temp rook 23. We'll cd to temp rook 23. Oops. And we will vi pass steal.sh. And we will bin bash. That's probably really hard to read. Sorry about that. And all we're going to do is we're going to write the simplest one-line script ever that will be executed by bandit24. We are going to cat etsy bandit pass bandit24 into temp rook 23 bandit24. That's it. It's going to execute this one-liner, and then it's going to delete that one-liner. So which is why we made it here, and we can just copy it over. So copy pass steal over to var spool bandit24. Now let's see if watch and say 3 seconds to 3 seconds LSL. So all watch does is just watch minus n is the number of seconds, and then it runs the command that I want. So every 3 seconds it'll update this. I don't know how often their script runs. Actually, probably what I should have done is also seen how var spool goes. There's nothing in var spool. There's nothing in here. Damn it. I remember having a lot of problems with this one. Let's see. Let's make sure that Bandit24 is allowed to do this. He might not be in the Bandit23 group. So plus X, this is kind of a cheap way to do the chmod stuff. So instead of having to deal with like the 664 whatever, you can just do +X, and that'll give it execute permissions to everybody. So now it's X across the board. So, and actually, I think this is going to solve it because it wasn't set to execute at all, even for me. And if we look, it's not bash. It's not running bash and then this. It's just trying to execute it right off the bat. And if it doesn't have an execute permission, it probably won't work. So let's put that in there. Ha! There's somebody else here. Is that one of you guys? It's not often you run into somebody doing these because, oh, and now they're gone. See if we got our stuff. Now! Why? Okay, I'm going to take a quick 2-minute break. I needed to take care of something real quick. When I get back, I have a couple ideas how to like way over engineer this thing, but give us some debugging capabilities. So I'll be right back. Okay, I'm back. I think I know what happened, but we'll still do the debugging in a second. Let's check this out. If we look, what if we ls minus al rook 23? Okay, what I think it is my rook 23 directory was not writable by that script. So by him writing that script. So let's try this one more time. Oh. Oh man, I want to read your script. Still didn't do it. All right. So what is the deal here? Okay, so here's what we're going to do. We're going to set up a Python listener. We're going to use the module basic basic HTTP server, and we're going to do it on port 9000. No, what? Pretty sure that's how it works. Python basic HTTP server. Base HTTP server. I usually work in Python 3. Not that I work much better in Python 3, but there we go. Okay, so we're going to VI pass steal, and then we're going to curl. We just want the headers. I believe that's what -i does. Excuse you. Okay, let's try. Uh, 7001. Rook 23. Okay, so we've got this listener listening on port 9000, and we have our script now is set up to. Why does it keep doing that? Okay, let's not use Python. CLP. Maybe 9000 is a bad port. I don't know. We'll find out. The script is now set up to connect and grab a. Yeah, it's the problem is 9000 probably. So we're going to do 46231. Probably get a lot less pissed about that. Okay, can we do the Python like that? 46321 or 46231. Okay, so now we're getting. It doesn't really matter that it's not working correctly, because now we're getting at least a status message that it got pulled, right? Or that they tried to get it pulled. So if we copy pass steal to var spool bandit 24, and we'll ls var spool bandit 24. Okay. Ooh, so that time it worked, but it's empty. Um, okay, what do we do? What do we do? Um, hmm. Why was it empty? Why is it empty? Okay, so the O plus W means other plus W. U plus W would be user. So once again, the three are the user, group, and other. Um, so just trying to add that writable bit, maybe. So yeah, it looks like, I don't know if that's one of you guys following along, but maybe. Neat. Ooh, hurry up. Mm, okay, they're both gone. I didn't get anything. Hmm. Why didn't this work this time? Oh, it did work. It just didn't want to show up. Ha. Okay, so what appears to be the case is that we need to add this file. And I think it's a permissions issue, I think is what it comes down to. We're trying to get another user to write to us. And we are creating all this stuff that doesn't necessarily give them permission to do that. This goes back to a concept called hack naked, which is basically don't have security, set up. Like don't have um, like security when you're trying to break into something, because your security will get in the way of bypassing their security. So um, we should have just made everything in this directory 777 and be done with it and get that working. So let's see here.